LPV stands for Localizer Performance with Vertical Guidance. LPV is a category of approach minimums for RNAV approaches that are typically lower than LNAV or LNAV-VNAV minimums. RNAV approaches with LPV minimums are built on the Satellite-Based Augmentation System, or SBAS. In North America and Hawaii, this system is known as the Wide Area Augmentation System, or WAAS. Other SBAS systems currently operating are the European Geostationary Navigation Overlay Service, or EGNOS, GPS-Aided Geostationary Augmented Navigation, or GAGON, and the Multifunctional Satellite Augmentation System, or MSAS. An SBAS system is made up of GPS satellites, a network of ground-based sensors, space-based geostationary communications satellites, and SBAS-capable GPS receivers. The ground-based sensors gather GPS signals and apply a correction to them. The correction data is then sent to a geostationary communications satellite, which in turn broadcasts the information to an SBAS-equipped GPS receiver on board an aircraft. The GPS receiver combines the SBAS correction signals with data from GPS satellites and produces highly accurate position data that is then used to fly RNAV approaches to LPV minimums. Prior to the development of SBAS, GPS was not able to provide the accuracy or integrity to achieve Cat 1 minimums during approaches. FMS navigation databases in SBAS-capable aircraft contain an additional piece of information for each LPV approach called a Final Approach Segment, or FAST data block. The FAST data block contains the lateral and vertical parameters that define the approach to be flown. An RNAV approach with LPV minimums combines information from the FAST data block with highly accurate SBAS correction signals to produce an approach that closely mimics an ILS. This increased accuracy allows LPV approach minimums to be as low as 200 feet and 1/2 mile visibility. Similar to an ILS, when LPV is active on an approach, course deviations are angular instead of linear, meaning the sensitivity of the deviations are increased as the aircraft approaches the runway. To explain further, on an approach using linear deviation, a 1-dot deviation can equal 75 feet at the final approach fix and 75 feet at the runway. Whereas on an approach using angular deviation, a 1-dot deviation can be equal to approximately 180 feet at the final approach fix, but only 18 feet at minimums. Angular deviations provide more precise approach guidance. Current ILS approaches use angular deviations. Approaches with LPV minimums are conducted using the Approach button on the guidance panel, which arms the LNAV and GP submodes. However, when the aircraft begins the final approach segment and LPV is active, the lateral and vertical deviations are no longer provided by the FMS, but are sent directly from the GPS sensor. Let's walk through an operational example of an approach to LPV minimums. First, select the appropriate runway. Then select the desired RNAV approach and approach transition if necessary. When selecting an RNAV approach with LPV minimums, LPV is the default minimum selection. Select Apply, review the approach, and then select Activate to load the approach into the flight plan. Each RNAV approach with LPV minimums is identified by a unique approach identifier, or approach ID. The crew must verify the approach ID on the approach chart and the arrival page on the MCDU prior to flying the approach, and on the PFD once LPV is active. After an RNAV LPV approach is loaded into the FMS and the approach is armed by the crew, the LPV armed annunciator is displayed in white on the PFD when the following criteria are met. The coupled PFD nav source is FMS. The coupled preview nav source is not Localizer. The FAST data block is loaded into the FMS. And the GPS is receiving an SBAS signal. Once an approach clearance is received, the approach mode is armed by pushing the approach button on the guidance panel. When the approach mode is armed, LNAV and GP are displayed as the armed submodes. The LNAV course is captured as a standard RNAV GPS approach. Approximately 2 nautical miles from the final approach fix, the approach annunciator on the PFD is displayed. Once LPV is captured, the RNP value is removed. The approach ID replaces the DME source annunciator, and the LPV annunciator is displayed in magenta, which indicates that the aircraft is now using high-integrity angular deviations directly from the GPS to guide the lateral and vertical path of the aircraft to make an approach to LPV minimums. When the glide path is captured, the altitude preselector can be set to the missed approach altitude. The GP mode and glide path during an RNAV approach to LPV minimums is similar to the ILS glide slope mode in the following ways. They both ignore the altitude preselector. They will not level off at the decision altitude. Both provide a stabilized approach path and allow for standardized approach procedures. And they have published decision altitudes that allow for a momentary dip below minimums during a missed approach. As the aircraft reaches the LPV decision altitude, the pilot may either continue to land or initiate a missed approach. When a missed approach is initiated and the toga button is pushed, navigation guidance automatically transitions from GPS back to FMS. When conducting LPV operations, there are a few important things to remember. LP minimums on RNAV approaches stands for Localizer Performance without vertical guidance. Approaches to LP minimums require different FMS navigational database information than approaches to LPV minimums. Currently, Honeywell platforms are not certified to fly approaches to LP minimums. Pilots must be familiar with the fail-down capabilities of their SBAS system. An amber X over the vertical path indicator, along with an amber LPV annunciator and amber approach ID, are displayed on the PFD when conditions exist that would prohibit descending to LPV minimums. The flight crew may have the ability to continue the approach to LNAV-only minimums if an amber LPV annunciator is displayed. Performing a missed approach and loading a different approach procedure should also be considered. Refer to your Embraer aircraft flight manual for guidance on SBAS fail-down procedures and requirements. Pilots must notify air traffic control of any loss of GPS or SBAS capability and state their proposed course of action. RNAV approaches with LPV minimums, together with SBAS systems, provide an efficient alternative to traditional ILS approaches. This video has been an overview of RNAV approaches to LPV minimums. Please be sure to refer to AC 90-107 or AMC 20-28 and your aircraft pilot manual for more detailed information.
When we think of the 5-year plan, the growth strategy will continue to evolve with our great portfolio. Sales over the next 5 years will be growing 4 to 6%, so that we should add 7 to 12 billion, getting to 46 to 51, and you'll see a lot of it just coming.